Hey, hi guys. So, welcome to another episode of Easing File. Now, in this episode, we are going to learn about strategy design pattern. Okay, so before learning about strategy design pattern and the official definition of strategy design pattern, so let's look at a problem. So, let's say we are developing a video game that is related to ducks. So, let's say that we have an duck class. So, let's create one duck class because examples are better. Let's create a duck class. So let's say this duck is an abstract class. All right. This duck is an abstract class which has some behaviors associated with it. Let's say it has a fly, not a fly, it has a quack behavior which makes a sound, and it has a swim behavior. All right. So this is an abstract duck class that has two properties in it, or two methods in it. Sorry. So one method, it makes the duck to quack, and another method, it makes the duck swim. So what can happen is now we can create an implementation class. Let's say a real duck, okay? And I'm going to say it extends this duck class. So now what we have to do, since it's an abstract method, let's say we have an abstract method that is display, right? So it has an abstract method called display. So in this real duck, what we have to do, just override that method in itself, just the display method. This looks like a real duck. Okay. So we have an implementation of this real duck class, and let's create another implementation. Let's say rubber duck, which is the basically a ducks that you can find in a bathtubs and so on. Extend the duck and override that simple method. Okay, this looks like a rubber duck. So why did we just made this duck method as an abstract? Because like different ducks looks in different kind of way, but the behavior, but the other set of behaviors can remain the same. So we have these two methods, okay? This two concrete implementation of duck and real duck. So now we need to introduce a new behavior onto our duck system. So that behavior is flying. Okay, that looks pretty simple at the first glance since like majority of ducks can fly. So what we can do, we can just shove that method in into this abstract class and then all the ducks can inherit it, right? So let's do that. Public void fly. Oh, now a method which flies. Okay. So that's a great idea and a great thing. But the problem is like the real duck flies, that's okay, that's cool, that this real duck can fly. But what about the rubber duck? The rubber duck cannot fly. So this fly method is actually should be specifically enabled for some ducks, and for some other ducks this fly method shouldn't be enabled. So this is a dynamic thing, all right? And also for this rubber duck, let's say that this rubber duck doesn't quack, it just squeaks, right? So what we're going to do, we're going to implement this quack method. Okay, this duck squeaks. So that poses a problem because this duck, rubber duck now can fly because we are inheriting it from this duck abstract class. Now we want to stop it, right? Uh, mhm. Then what we did recently now with quack method, we have to also do with your fly method, right? Then we can override it that this duck doesn't fly, right? We can do that. That's possible. But the problem is like in the future, many of such concrete implementation can happen and it is not possible to override that, right? And also at the runtime, we will not be able to switch out this functionality of the quack method or the fly method because they're concrete implementations. We're going to switch it anyway. That seems to be a bit of a problem. But what can we do is we can create an interface, right? We can create an interface called flyable and quackable and just make this like implements flyable and quackable like this. If it implements flyable and quackable, we can override the fly and the quack method over here. But that also poses a problem. The problem is this each of this individual implementation, they need to have this flyable and quackable. All right, that is quite a gist. Then how can we solve this problem? So let's say that instead of doing this, all right, we create some behavior classes that encapsulates into that fly behavior and the quack behavior. What do I mean by create behavior classes and encapsulating them? So let's look at that. So let's create a new package, call it as fly. Okay. Let's create a new interface, fly behavior, which just has void of fly. Okay. Nothing else. Public is not required. And let's say we have a new Java class, fly with wings, and it implements that fly behavior. This duck can fly with wings. All right. So we created a concrete implementation with fly with wings. Let's create two more so that we can test out our classes. Then fly Norway. Fly behavior. Okay, so this duck cannot fly. Okay, all right. That is a good thing. Now we have created a set of behaviors. We have created a fly behavior that corresponds to this interface. Okay, so there are different algorithms for this fly behavior, and we have encapsulated it with our interface. All right, so these are behavior classes, and this is the interface that encapsulates all these behavior classes. So let's create the same thing. Let's create this quackable interface, or rather quack behavior, and it's going to have quack, right? So let's create quickly the concrete implementation. This stuff can quack, and another implementation. Let's do it quick. This stuff can squeak. Okay. Hmm. That is a great progress so far. So we have created. So let's close all the tabs. Okay. So we have created a fly behavior, which encapsulates all the flying algorithms. And then we have encapsulated a quack behavior, which encapsulates all the quacking algorithms. Okay. Now, how can we integrate this set of functionalities to our real duck and the robot duck? So that's where the magic comes in. We can use composition to do that. So in our duck class, what we can have is a private fly or quack behavior, and we have to import it, and private fly behavior. All right. So now we're going to create a constructor for this duck so that the concrete implementation has been there, and the fly behavior. Okay, so we have created these two interfaces, uh, two instances of this quack behavior and the fly behavior. All right, and now instead of this quack, since this all the behavior is dedicated to a separate class, what we can do is just replace it with the quack behaviors, quack method. And similarly in the fly behaviors, what we can do is fly, fly. All right, and we can rename this as perform quack, and we can rename it as perform fly. All right, so these are the methods. So let's go and quickly check over the robot duck and this duck. So it needs a constructor, right? So in the constructor, what we can pass in is new quack, because this really quacks, and new fly with wings. All right. Now inside the robot duck, we are going to do the same thing. Now we see that we have the quack implementation. We do not need that since we have separated it out. So now robot duck would have the super, and it doesn't fly. So new fly no wing, and doesn't and it doesn't quack, it squeak. So squeak, right? 1 minute, I may have fly behavior. It is fly. Okay, quack. Oh, I've just misplaced the. Yeah, now it works. So we have a rubber duck which cannot uh, which cannot quack and cannot fly. So it has a squeak functionality, and as it cannot fly as behavior. And this is the duck. All right. So let's go to the duck driver and create a public method. Go with duck new, not rubber duck. Let's go with real duck first, right? And let's import this duck dot perform quack, duck dot perform fly. And if you just run this code, we should see this duck can quack and this duck can fly with wings. What is the benefit of using composition in our duck abstract class and not, extending these behaviors into the concrete implementation? That's a nice way to put it, because at the runtime with object composition at the runtime, we can swap out the implementation if you want, and we can make, you know, this real duck do something else than, quacking or flying with wings. So that's the magic of software composition. So what we need to do is we need to have a getters and setters method. Okay, so let's generate those getters and setters methods. So you don't need the getters method, just the setters method would do. Why we did that? So let's, in our fly interface, so let's create a Java class, and let's call this as fly with rockets. Implements behavior. Okay, this duck is flying with rockets. So let's go over here and create a new rubber duck equals to new rubber duck. All right. So let's go and import this rubber duck dot perform quack and rubber duck dot perform fly. All right. If we do this and run it, we'll see this duck can quack, this duck can fly with wings, and the rubber duck can squeak. This duck cannot fly. So what we can do now is we have rubber duck dot set fly behavior and fly with rockets. Now we do not need to print it out, just rubber duck dot perform fly. Now this duck is flying with rockets. Pretty cool, right? At the runtime, we're changing out the behavior. So this is what strategy pattern is all about. Strategy pattern states that move all the changing components of an class into separate entities, into separate algorithms, which is encapsulated by an interface. We are not over here, we do not have concrete implementation, we have interfaces. So this can be anything that implements a quack behavior. So it can be any set of algorithm that we can use, and this will be dynamically by the use of polymorphism be called over here. So this is strategy pattern all about. Thank you guys for watching this video. See you in my next one. Until then, bye bye.